Hey, I'm that guy who codes, and I'm going to show you a Facebook interview question that I was asked a couple weeks ago and really trudged through the problem and made quite a big mess of it. But we're going to go through it so it doesn't happen to you, and hopefully you learned something from the video. So let's dive into it. What's the question? Well, you are given a string that is a formula with parentheses. It doesn't really matter whether these are numerical characters or like letters. You just need to take the input string, see if the parentheses are balanced, and then if they are not, you need to balance the string and return the corrected string. So what does that mean? So that means that if you're given this string, you would see that, okay, well, this parenthesis doesn't have an accompanying opening one. You would delete it. And then you would see these two, and you would say, okay, well, the second one gets closed eventually, but this first one doesn't actually ever get closed. So we need to delete that one and these four guys who are just hanging out here on the end. We will return this string and then feel good about ourselves because we did it correctly. So basically, whenever you see a type of question where you want to balance parentheses, you want to be thinking about the stack data structure, which I was not, and admittedly it was kind of dumb the way I first tried to implement it, but we won't talk about that, and we'll really just give you the answer. So you need to think about two cases when a string could be wrong. First being you have an invalid opening parenthesis, and second being when you have an invalid closing parenthesis. So I'll give examples of each. So first, this would be an invalid opening parenthesis where you have some string like this where this opening parenthesis doesn't actually have a buddy at the end to close him. Secondly would be a string where you have something like this where you have a closing parenthesis and no buddy on the other end to actually make the string valid. So the invalid closing parenthesis you can usually sense right away if you use a stack, because when you use a stack for parentheses, you're going to push onto the stack every time that you see an opening parenthesis and then pop off of it every time you see a closing one. So if your stack is ever empty and you see a closing parenthesis, you can tell right away that this parenthesis is valid. So that case is usually pretty easy, is to sense when you have an invalid closing parenthesis. The harder case to take care of is when you have an invalid opening parenthesis, because you won't know until the end of the string. So how you would approach this is that you would push these two opening parentheses onto your stack. You would see that this ending parenthesis would close it, and then you would pop off the index that you saved for the opening parenthesis. So in this case, let's walk through how that would work. So you would push on index 0 for the string because this is an opening parenthesis. Then you would move on and see that this is an opening parenthesis as well. You push on 0 or index 1 to your stack, and then you'd ignore the number and then pop off from your stack because you see that this guy closes the parenthesis that we saw at index 1. So now you would just be left with 0, and you know that you need to get rid of the character at 0 because this is the opening character or parenthesis that makes the string invalid. So what does that look like in code? So I'm going to use a vector of integers, which are the indices within the string, as my stack, and I'll pop and push to the back of this vector since it's a constant time operation. So we iterate through the input string character by character. If it's an opening parenthesis, we will push back to our vector, and if it's a closing parenthesis, we will either pop back from it if there is at least one index for an opening parenthesis in our stack, or if it's empty, this is the case where we see an invalid closing parenthesis like this second example above. So if we see this, our stack will be empty, so the size will be 0. And then we can just mark this as an invalid character. That's what I'm doing here with a star. That's just any special character you could use would work. But you mark that as an invalid character so you can delete it later. So that's the two cases, or that's the second case. So how do I deal with this first case where we sense an invalid opening parenthesis? Well, if at the end of iterating through our string we still have indices in our stack, we know that there was no accompanying closing parenthesis for all these indices in our stack because we never popped them off. So I'll iterate through each element in our stack, V, and mark it with a special character. Now, the easier way to do this is to now declare a string, a return string, and then for each character that is not the special character, you can add it to that return string and then return the string. And that was the answer that I eventually got to after an hour and plenty of hints during this interview. However, Facebook is not going to be happy with that, and they're going to want you to go a step further. And now the question is, how can you perform this algorithm without declaring any extra space, aka this string? How can you reuse the input string and return the corrected parenthesis string? So I've written another function which is the exact same up until this point. Then we'll move on, and we need to declare an offset integer, or at least I believe that's the only way I could figure out how to do it. And what this will do So what's different about this approach? We need this offset. I'm going to explain what this does with a sort of demonstration rather than just diving into the code. So let's say that we have a string like this, and I don't know, 554, and we have 2 more opening parentheses than we need. So we would say, okay, these 2 are on our stack, this parentheses on our stack, and this parentheses on our stack. Now once we see this one and this one, we would pop off the opening parenthesis that is here and here. Now we're left with these 2 indices, 0 and 1, mark them with our special character. Boom, boom. So these are the 2 characters we need to delete, and this is the string that we need to return. So this can be accomplished without any extra memory by reusing the input string. So what the offset does is the offset will start at 0, and we'll have an offset of 0. So every time that we see a special character, we will increment this offset. So we'd see this special character, okay, offset is now 1. See this? Okay, offset is now 2. So what that does is when we basically want to copy this string over to the beginning of the input string and then be left with whatever garbage is at the end of the string, which would still be these 2 characters, and then you can pop the back of the string, which is just deleting the element on the back of the string, like this, which is a constant time operation. And then you don't use any extra memory, and we're all happy. So what the offset does is says, okay, well, I need to copy to this position in the string, but I don't want to keep this character. I need to overwrite it. Okay, well, where's the next valid character? Okay, well, it's not this one, and it's not this one. I need to copy 5 into the beginning position of this string. So what's going to happen is I need to copy index 2 into index 0 for this string. And the offset is just where the next valid character is, plus the index that you're currently at. So we would have 0 plus 2 is the character we want to copy. We want to copy it into 0. So the index will increase. We'll just loop through the entire string. But as we see invalid characters, we're going to increment this offset in order to copy over the string correctly. So what that looks like in code is this function here. So actually I'm going to do this and zoom back in. So offset starts at 0. Okay, while we're going to iterate through the entire string and make sure that I plus offset is not going off the end of the string, we are going to increment the offset every time we see a special character. And we want to hit this in a while loop in the case that there's multiple invalid characters right next to each other. So in this example above, we would set the offset to 2, and then we would just copy index 2 into index 0. And now every time that we copy over, we're accounting for the offset of these invalid characters. And then at the end, we would just pop back the number of invalid characters that we've seen, which is equal to this integer offset. And then we would return the input. So that was kind of the next step for this problem that makes it harder and kind of makes you think about it. The worst part of this second strategy was definitely the indexing and figuring out how to copy over the string correctly and then also delete the invalid characters. But this is how you do it without any extra memory, and this is the regular solution that's easier but also requires you to declare a new string. If you don't understand what a stack is, I will link in the description some videos and information about what it is. And if you have any questions, comments, concerns, leave a comment, tell me I suck, or that none of this made any sense. That would be great to get any feedback if anyone actually watches these videos. So if you stuck through this far, thank you, and if you want me to do any more coding problems, just again leave a comment. Thanks.